result of the PSD. And then I didn't bring my computer because I didn't think I was going to do any Unisim today. But if you go into Unisim, there is something called workbook. And that prints all the values of variables. You don't have Unisim installed, do you, on this? Can I borrow your computer to show them then? If you would install your computer here and log into Unisim, then I can install them. Yeah, I didn't bring a computer because I didn't intend to do anything in Unisim today, but forgotten about that. Good night. You can project it here.
I have a question. We know for the original line of questions that you gave us age is but shouldn't that have like a T in front of it? You told me you gave us two T's of what but then as well as H, so shouldn't you multiply that by T?
H is integral CPDD.
Yeah, but it has like a T on it. I'll show you after class. I'll show you after
But CP is partial H with respect to T. So DH is CPDT. So H is integral CPDT. There's nothing else. Okay, let's get started, and at some point I will show you something in Unisim. So and Jamie, you're being added. Cynthia is back, so now we can do things. Hopefully well rested. And also those of you who are in research, I can't stay longer, but immediately after class, if you're doing research, I can tell you who you've been assigned to, okay? Save me to send a few blessing notes. Okay, so the last thing we did on Friday was to talk about the triple product rule. And the easy to remember form is let me write it in this form. Partial y with respect to x at constant z, it rotates, times partial x with respect to z at constant y times partial z with respect to y at constant x equals minus 1. Or if we solve for partial x, partial y with respect to x, that means that partial y with respect to x equals minus, moving this to the other side and flipping them to put them in the numerator, I will get this flip gives me partial y with respect to z at constant x times this flipped partial z with respect to x. There's a minus in front, very important, at constant y. I hope you can still read. Clear? So that's the triple product. This should not be confused with the.
Forgot the constant z.
What did I forget?
Constant z on the left hand side.
Oh. With the chain rule, which has the same, kind of the same type of derivative, but quite a bit different result. So if I have y, x, and z as 3 state variables, so that means I need to define the third, or we can express any one of them as a function of the other two. So y is a function of x, z. That means so y is some function of x, z. That means that the differential of y is equal to the partial of y with respect to x at constant z times dx plus the partial of y with respect to x at constant partial with respect to z at constant x dz. Okay? So I can change this to any partial if I take all the d's to be the same partial. So let's calculate the partial of y with respect to a k at constant z. So from here, I can write that partial y with respect to a k at constant z. So I'm changing the differentials to partial with respect to k at constant z. Okay? So that is equal. First term, partial y with respect to x at constant z, and the dx becomes partial x with respect to k at constant z, plus partial y with respect to z at constant x, and then the z becomes partial z with respect to k at constant z.
What is k?
Anything. Okay? With me, everyone? Okay. What is partial z with respect to any k at constant z? 0. So this goes away. And let's do some renaming. Let's change the name between k and x. So rename k into x and x into k. So that means I get partial y now, k becomes x, at constant z equals x becomes k, partial y with respect to k at constant z times partial k with respect, k becomes x becomes k becomes x, okay? With respect to x at constant z. Let's compare this expression and this formulation of the triple product. In both cases, I have the same partial derivative on the left-hand side. Here I have partial y with respect to z times partial z with respect to x. Here I have partial y with respect to k, partial k with respect to x. Here I have a minus, here I have a plus. What's going on?
Well, also on that one you have c being constant for every single one. The one you have x being
Absolutely.
constant. One more time.
Very correct. The difference is, in the chain rule, we keep, what we keep constant is the same. Right? While in the triple product rule, three different things are constant. Okay? So don't get the two confused. Just wanted to make sure that we're okay. All right. Are you benches ready? Good. Let me interject something on how to do the homework, on how to report the homework. So if you would project here, anything, you'll have some homework with Unison. Whenever you have Unison homework, you need to submit hard copies of two things. A screen capture of your PFD, which is the main screen. And now you need to come here and help me know how to project. Let's see. I hope it has this. Yeah, that'll be mine. Oh, boy. Oh, well.
Does it have, no, it doesn't have VGA either. Mini HDMI?
Anybody has a mini HDMI converter?
I have HDMI on my computer.
But you have a converter, so we can use her computer.
Plug in his
Do you
computer.
want to just plug in my computer? I have Unison open. She's already got this thing.
Yeah, okay. If you're to load any Unison would work, any Unison at all. Okay. Thank you, Mark.
I didn't save the homework, but.
I think it's on the other side.
Ah, okay.
Oh, yeah.
Should be coming up. Do you have anything Unison saved? I'll pull up any file, doesn't matter which file I'll pull
I
up.
think I have the example from.
Yeah, that's it. Yeah, mix it, okay?
Actually, that might be it.
All right.
Maybe it's the one.
Okay, good. So let's say we have a Unison file. So you need to print out this picture, that's the PFD, and then there is something called workbook. And you need to do a modification before you print it. You find the workbook with the picture here. Right now, notice the top one doesn't allow you to do anything with the workbook. But the moment you select workbook, notice the top bar now has a listing workbook. Right now, the default shows temperature, pressure, etc., but doesn't show any compositions. To have only one printout, I mean, you could do separate printouts, but to have all one printout, click then on workbook, setup, that only shows up after you have clicked the workbook picture. It won't show up without. And click add, and component, let's say mole fractions. Sorry, here, on the variable, not on string. Click add here. Okay, this add right here. And select component mole fraction and select all. And you can see here, now if you had more components would show up, select all and click OK. You can see now, the moment we did that, for all components, the mole fraction would be appearing on this. print that out. So for any homework you submit in Unisim, print out of the PFD and print out of the workbook with the component mole fractions added. And with that out, you can easily see if they have done it correctly. Clear, everyone?
So we should be doing that for every problem if there's a different
If there's a Unisim, yes.
part.
For any Unisim problem, you need to do it. Okay. Thank you, Mark. Do you have any reason you want to save this or not? I want to save it since I've had it up, I would say. I will not say anything. Shut up. No. All right. Thank you.
Don't worry.
Okay, that. From this point on, I'll be using a board notation, a board numbering of equations, the same as your textbook. That will make it easier to reference your textbook. Also, when I go in the future to multi-component situations, I can be referring with the equation number that we have, okay? Because if I number them 1, 2, 3, and I say 1 month from today, oh, they listened, so equation 3. That's not very good. So I'll start here by putting a very important summary of relationships. And I will use, as I just said, text equation. So write the expressions both for open systems and for closed systems. We already have derived, starting with the energy balance. And that is equation 6.25b. Okay. And we also derived what is du for an open system with one stream dn, and that would be du equals dds minus pdv plus, do you remember what goes in front of dn? G.
I think you switched. You switched them.
Yeah, the labels on the top are switched.
Oh, yes. Oops. Thank you. Yep. And that's 625A. So. So the open system equations. And if we use H equals U plus PV, the differential of PV cancels the minus PdV and adds a VdP. So working with H equals U plus PV gives us DH equals TDS plus VdP, and again we did that earlier this semester. And that is 6 to 6b. And we didn't do it for the open system, but exactly the